All right, here we go. Very last part of 3.4. You can see now we're going to look at equations. So I'm going to put actually what I should have here, instead of just having logarithmic functions, it should say logarithmic equations. The first video we went over exponential equations. Now we can go back and forth between exponentials and logarithms because they're inverses. You're going to see a key for this. When we have a logarithmic equation, if we can put it back in exponential form, then we can do basically what we did on the first video to solve for it. Now I kind of separated these equations into three different sections. The first section is probably the easiest. If you only have one logarithm, no matter which side of the equation it's on, there's two key steps here. Okay, and this is what you can take down. The first one is you kind of want to treat the logarithm like it's a variable. You want to get it by itself. So we'll say isolate the logarithm. Okay, get that logarithm by itself. Now that could be natural logarithm or just a normal logarithm with whatever base we're working with. Then once we have the logarithm by itself, we're going to put the logarithmic equation back into exponential form. So we'll say put back into exponential form. And then we'll be able to solve for x. So we'll say, I'll just abbreviate that, put back into exponential form. And that's kind of using the definition for logarithms. All right, we're going to do, let's see here, for this first section, we're going to do number 1 and number 3. So one of a natural log and one of just a normal logarithm. Now number 1, if I look at number 1 right here, this natural log, it's already by itself. So step 1 is already done for me. The natural log is already by itself. So I want to do this step right here. I want to put this into exponential form. Well, natural log, remember the base is e, so I'll write a little e down there. When I put this back in exponential form, right, I do a little circle, it's e squared equals the argument of x. And that's pretty much it. Just use your calculator to figure out what e squared is, and that's what x equals. So if we did e squared, let's see here, let's just go right to the answer. Okay, if we did e squared, x is going to be, okay, this would give us around, I kind of rounded this right here, probably around like 7.34. So that's what x would equal there. Okay, very easy one. Let's skip to number 3. Now number 3, here's the big thing with number 3. You want to get this by itself, the log base 5 of 3x. Now the logarithm, it's not completely by itself. And in order to do that, it's 2 times the logarithm. So you want to get the log and the argument, which is 3x. You want to get that completely by itself. So I'm going to divide by 2. That cancels out. Divide the right side by 2. So then I have log base 5 of 3x. And 4 divided by 2 gives me 2. Now I have this logarithm completely by itself, so I'll put a little check mark there. Now I need to do this. I need to put it back in exponential form. And before I do that, I'm just going to show you a common mistake. What some students will do, they'll divide. I'm just going to show you a mistake right here so you don't have to take this down. They'll try to divide this by 3. All right, leave the argument the same. Don't do anything with the argument. You want to get the logarithm and the argument by itself, so we don't want to do this. Okay, even if it's like 4x or x over 4 for the argument, leave that the same. So now if I want to put this back in exponential form, I do a little circle here. Oops. Okay, so this is 5. So I do a little circle here. It's 5 squared equals the argument 3x. Right? 5 squared equals 3x. This is exponential form. And then it's a very easy equation. 5 squared is 25. This equals 3x. Very simple. Just divide by 3, and we're going to get our answer. Our answer here, I'll just put right here, is 25 thirds. Or if you're making a mixed number, it would be what? 8 1/3. So that's what x equals. Okay, let's move on to the second case. Okay, and for the second case, we're going to do number 5. Number 4 we'll do in class tomorrow. All right, now this one right here, we have more than one logarithm on one side of the equation. And basically what we want to do here is here's the key. Since we have more than one logarithm, we want to condense to one logarithm. So we're using our properties that we learned in the last section, 3.3. So we'll say condense to one logarithm. Okay, so we're just going to do number 5. So if I look at the left side, that's where I have the logarithms. I want to condense this to just one logarithm. So I'm going to keep the same base at 10. And then when I condense, since this is adding, when I condense it, the arguments 5x and x minus 1, I'm going to multiply those. So it's going to be 5x times the quantity of x minus 1 equals 2. And then now it's just like the problems that we did for the first section. You isolated the logarithm, so now you put this back into exponential form. So when I put it back in exponential form, it's going to be 10 squared equals the product of 5x and x minus 1. So I'll write this out. 10 squared equals the product of the arguments, 5x and x minus 1. Okay, so this is going to be 100. We distribute the 5x. We're going to get 5x squared minus 5x. All right, and then, again, it's going to get a little sloppy right here. I want to move the 100 over to the right side. So when I do that, I'm going to subtract 100. So I'm going to have a quadratic that's 5x squared minus 5x. When you subtract 100, you have minus 100, and that equals 0. So you have a quadratic, and the quadratic you always want to set equal to 0. All right, now I'm just going to erase this right here. I'm going to erase all of this right here. Okay, so we have a little bit of space. All right. And when I basically want to factor this, but I could factor out a 5. If I factor out a 5, I'm just going to put this work right up here. I factor out a 5, I'm going to have 5 times the quantity of x squared minus x. 5 goes in 120 times, so it's minus 20 equals 0. And then this is going to factor. So good, you don't have to use the ugly quadratic formula. This quadratic on the inside factors to x minus 5 times the quantity of x plus 4. And then when you solve for these, you get x to equal 5 and negative 4. So this one, you get two solutions. Now here's the one thing. When you take the logarithm of numbers, it cannot equal a negative. This negative 4, when you plug this in, when you plug that in there, you get negative 4 minus 1, and that's negative 5. You can't take the logarithm of negative 5. So these cases, some of these you're going to get extraneous. So just remember, you cannot take the logarithm of negative numbers. So this is extraneous right there. So the only answer here is x equals 5. Because if you plug 5 into these, you're still going to get positives. You're going to get log base 10 of 25, and here you get log base 10 of 4, because you do 5 minus 1. All right, the last part. Okay, and again, I'm going to erase things here. The last part, I'm going to do 6 and 8. Okay, if there's logarithms on both sides of the equation, what we want to do here is we want to condense each side so there's one logarithm on each side. So let's say condense to 1 log on each side. Okay, that's the key. So we want to have 1 logarithm on the left, 1 logarithm on the right. And then once we do that, then we just set the arguments equal to each other. So we'll say set argument equal to each other. Again, I apologize for how sloppy this is, but this is as small as I can write it. You should be able to write it a lot smaller and fit it in. So we're going to follow these 2 steps. Now, if we look at number 6, this is actually, step 1 is already done for us. There's 1 logarithm on the left, there's 1 logarithm on the right, and you're always going to have the same base. If you don't have the same base, then you can't solve for these. So you're always going to have the same base for these. So then, if I want to do step 2 here, this is very easy. All I do is I set these arguments equal to each other. So I literally can cancel out the log base of 3. So you're just going to have 5x minus 1 equals x plus 7. And it's a simple linear equation you solve for. Right, we can subtract x from both sides. So it's going to be 4x minus 1 equals 7. So you're going to have, after you add 1, 4x equals 8. Divide by 4, you get x to equal 2. Very, very simple one. All right, just set the arguments equal to each other. And if you plugged x equals 2 in there, like here would give you 2 plus 7 is 9. Here it would give you 5 times 2 is 10. 10 minus 1 gives you 9. So it works. It's not extraneous. All right, very last one we'll do, number 8. Okay, now if I follow this, the left side, I already have that natural logarithm by itself. I can't condense that anymore. So it's natural log of x plus 5. The right side, I have 2 natural logarithms. Now, since it's minus, that means when I condense it, I'm going to divide. So it's going to be natural log of x minus 1 over the quantity of x plus 1. And then these kind of, once it's a 1 natural log on both, these kind of go away. And I just set the arguments equal to each other. So then it's x plus 5 equals the x minus 1 over x plus 1. And then for this, what I would do is this x plus 5 I would put over 1, and then I would cross multiply these. Now when you do that, you're going to have to FOIL out the x plus 5 and the x plus 1. And then this is just going to give you x minus 1. So you're going to wind up getting a quadratic. This is going to be, let's see here, x squared. I'm just going to FOIL this out. It's going to be plus 6x and then plus 5 equals x minus 1. Now, as soon as you have a quadratic, you want to get the quadratic completely by itself. You want to set it equal to 0. So I would subtract x, and then add 1, and add 1. So we would have, let's see here, x squared. This is going to be plus 5x. And then 5 plus 1 gives us plus 6 equals 0. And then we would factor this. This is going to factor. So no quadratic formula in this video. This is going to factor to x plus 3 and x plus 2. And then when you set these factors equal to 0, you get x to equal negative 3 and negative 2. And then what actually turns out for this one right here, these are both negative. So when you plug them in, it gives you negatives. These are both extraneous. So I'll write extraneous. Hopefully I spell it right. I think this is it. Okay, I can't fit it in there. These are extraneous solutions. So we say there's no solution to this because both of these are extraneous. So we did all that work. We factored in. We did everything, set the arguments equal to each other. And then we wound up getting nothing for the answer. That can happen sometimes. All right, so the other ones we'll do in class tomorrow and then obviously do more practice with solving logarithmic equations.